Okay, respected chairman, dignitaries, ladies and gentlemen, my topic is behavior of geopolymer concrete with nanomaterial addition, as already you have mentioned. So,
This corner one. Yeah.
So why this study is necessary? Because the study of the behavior of cement-based concrete and also the effect of nanomaterials in geopolymer concrete also necessary. So earlier, that means some studies has been done based on the effect of nanomaterials on cement-based material. But as you know that cement, so the cement basically very useful material of the so-called the cement-based concrete. The cement production is not an eco-friendly material because 1 ton of cement production means almost 1 ton of carbon dioxide emission in the atmosphere. So from the greenhouse gas emission, that means a point of view, so we can search for the alternate that product concrete. That means basically if it can be made with cementless concrete, that is the geopolymer concrete. So geopolymer concrete is a special type of concrete which is an inorganic polymer produced by the alkali activation of aluminosilicate that can be used instead of cement-based concrete. So what is that means why the geopolymer concrete is required? So to reduce the carbon dioxide emission, to get the high oil strength when dry heat of steam cure is necessary, gives good resistance in alkali and sulfate attack. Fly ash and other waste materials can be utilized fruitfully, that means for production of concrete. And what are that means common type of material used for the production of geopolymer concrete? So basically low calcium fly ash from thermal power plant, coarse aggregates such as cast stone, other type, fine aggregates such as river sand, alkaline liquid, sodium hydroxide, sodium silicate, alternate potassium hydroxide, potassium silicate also can be used, but that is a little bit costly. Sodium hydroxide, sodium silicate is comparatively economical solutions. So why nanotechnology in concrete? Because you see that nanotechnology is mainly the manipulation of the matter on an atomic, molecular, supramolecular scale. The binding mechanism of concrete in the cement paste, in the cement-based concrete or geopolymerization for geopolymer concrete are taken place in the nano scale. So nanomaterials, so definitely nano addition can, in a range of size 1 nanometer to 100 nanometer can be utilized to improve the properties of concrete. Practically, the application of nanotechnology in other areas are already widely utilized. So in the construction industries, compatibility is less utilized, so the possibility should be more, that means explored. And effect of nanomaterials in concrete. So basically, it improves the material's properties to obtain the slender members. And you can get the quicker setting time. So bring down the weight and cost-effective lower level of environment contamination and allows for rationalization of the design. And improve the carbon rating. We can reduce the carbon emissions. And nanomaterials that is used in the present study, we use the nanosilica, carbon nanotubes, and nanotitanium oxide. And nanosilica, so it is basically the first nano product used in the concrete to replace the microsilica. Earlier, the microsilica, silica fume was widely used for improvement of the concrete, particularly for the compressivity and the other properties. And advance made by some studies on concrete at nanoscale have shown that nanosilica may be a better option than microsilica in concrete. And that means some specific property to the nanosilica we have used the different depending on the, that means concentration, solid concentration, and the specific gravity. We have used the third type. And regarding the carbon nanotube are molecular scale tube that basically made from the graphite carbon. The excellent properties very much. It can, that means, increase the flexure and toughness of the concrete. They can be several millimeter in length, in one layer, single walled, that means nanotube or multi-walled nanotube. So general properties, the fuel CNTs are also highly flexible. Mechanically, CNTs appear to be one of the strongest material. they have smaller diameter, they have the stiffness and strongest fiber, they are very good for the, that means fire rating, fire resisting. Some of the specific properties of carbon nanotube use the diameter, length, and purity, amorphous carbon content, and specific surface area, and the bulk density. And nanotitanium oxide, that is nano, which they have used, that is why it is having the excellent self-cleansing property, unique property resulting in the improvement of the compressive strength of cement paste, mortar, and concrete. Also, it can be, that means, increase the strength of the geopolymer concrete. Nanotitanium oxide can be manufactured from beach sand, one of the available. And specific properties of the nanotitanium oxide have used, that is the pH average particle size, bulk density, water solubility. And nanomaterials, so we have incorporated in the geopolymer concrete in the dose of nanosilica, so starting from 0.75% by weight of cement, 3%, 6% carbon nanotube. After that means trial, this is the optimized dose, because you have tried the similar, that means percentage in the cement-based concrete. So after getting the optimization, you have used the same similar percentage after the geopolymer concrete, that means to get the performance. So nanosilica, we use this percentage. Carbon nanotube, we have used the optimum, that means percentage 0.02% by weight of cement. Titanium dioxide, this should be nanotitanium dioxide, 1% by weight of cement. And we have that utilize the curing condition. The geopolymer samples are first air cured in the air for 48 hours after casting, and then heat cured at 60 degrees for the next 48 hours. After that, the samples are kept in air in the ambient temperature till the test. And test performed the compressive strength test, non-destructive test of the rebound hammer, ultrasonic pulse velocity, EH test, RCPT test. I've used some of the resistivity test also. The test result for the geopolymer concrete to the various types. The first one is the control concrete, 0.75%. Then the nanosilica, 3% nanosilica, 6% nanosilica, and 0.2% of carbon nanotube, 1% titanium oxide. We have found out the nanotitanium oxide gives the maximum compressive strength, while among the silica, that means nanosilica, so we have obtained that the percentage. So definitely, if you increase the percentage of nanosilica, so you get the, that means, decrease in the strength. So definitely not only the cost effective, so that definitely we can use the lesser amount of nanosilica, so that will be advantageous. Because, and the rebound hammer, that is the non-destructive test, because in the real life structure we cannot destruct the samples. So by using the indirect test, non-destructive test, rebound hammer, one of the most widely used type of test, from which you can predict the strength of the existing structures. So we have that misuse as a rebound hammer. Normally, whatever the standard calibration curve is available, means the cement-based concrete, we have that means verified whether the similar same curve is applicable for the geopolymer concrete, or in that means incorporation of the nanomaterials. So these are the some values, that is the regarding the rebound hammer at 7 days and the 28 days strength. These are rebound numbers for the control concrete without, that means nanosilica, that is 0.75% nanosilica by weight of cement, 3% nanosilica, 6% nanosilica by weight of cement, 0.02% carbon nanotube by weight of cement, 1% titanium oxide by, that means, by weight of cement. And these are the rebound numbers from with the predicted strength, the 7 days, the 28 days strength. And so next we have, that means, done the ultrasonic pulse velocity test on the geopolymer concrete. This test is mainly done for the, that means, to predict the, that means, quality of the concrete in terms of the, because of the concrete is quality in the form of dense, or the properties in the, whether there are any cracks or voids or in the within the matrix system. So depending on the, that means, velocity, there are calibration chart available for normally the cement-based concrete, depending on the quality of the concrete. So we have that means verified whether the, that means, geopolymer concrete, particularly for the incorporation of the nanomaterials, whether the same curve is valid for the geopolymer concrete. That means we have done the ultrasonic pulse velocity test for the 7 days and the 28 days. And what are the, that means, for the different, that means, incorporation of nanomaterials. And what are the, in general, that means we have found that definitely the ultrasonic pulse velocity result is comparatively higher than the corresponding, that is the cement-based concrete. And we have that means tested there is some pH, the change in the pH for the incorporation of the nanomaterials. Because basically for the geopolymer concrete, particularly for the cement-based concrete, so the pH, normally the initial pH in the range of that means 12 to 14, more than 12. For geopolymer concrete, normally that means that the initial pH is less than the cement-based concrete in the tune of 10 to 11. So what is the effect for the further incorporation of the nanomaterials, nanosilica, titanium oxide, or whether the, so we have found out that after that means when the incorporation of that means nanosilica, titanium oxide, we have found out that that is insignificant variation of the pH of the incorporation of the nanomaterials. And this is that means that some electrical resistivity test that we have done, that means for that means geopolymer concrete, that is so we have used that means, so we have found out that the geopolymer concrete for the electrical resistivity, that is indirect, that means measure for the resist, that is resistance against the possible corrosion, because if the resistivity is more, the possibility of corrosion will be more. If the geopolymer concrete is used in the reinforced concrete member or pre-stressed concrete member, so what is the possibility of the, definitely the corrosion in the embedded this concrete, that is electrical resistivity is a indirect measure. So we have found that electrical resistivity definitely found that the incorporation of the titanium oxide, nanotitanium oxide, electrical resistivity is increased. So in that means electrical resistivity increase means, so definitely the possibility of corrosion will be less. And so even that means with respect to reference concrete, if we incorporate the nanomaterials, definitely electrical resistivity is increased. So this is definitely indirectly, that means will increase the durability. And there's some of the conclusion, the major conclusion, that nanosilica and also the titanium oxide can be added with low calcium fly ash based geopolymer concrete to get satisfactory, that means the amount of compressive strength. So predicted equivalent compressive strength obtained from the rebound hammer, rebound number using standard curve for cement concrete shows almost similar result after crushing of the geopolymer concrete. And for that means actual 28 days compressive strength is within the range of the predicted equivalent strength using standard curve for cement concrete, but at 7 days actual strength is much higher than the predicted strength. This implies the surface hardness of geopolymer samples are poor at 7 days of testing, whereas 28 days and onward the surface hardness is good. That is for the geopolymer concrete, that is more or less the similar tune of the cement-based concrete also. And even the ultrasonic pulse velocity of the geopolymer concrete samples is very high value, both 7 and 28 days for assessing the quality of concrete, as per the table mentioned for the quality of equivalent cement concrete as per the IS code or corresponding that is the ASTM code also. The table is as per the IS code can be modified. It is necessity for the modification for suitability of the geopolymer concrete. So some modification is necessary. And 28 days test result for the pH of geopolymer samples are almost similar for all cases of geopolymer samples, control or incorporating nanomaterials as well as OPC samples. Similar results for the pH is due to the use of alkaline solution as a source material in case of geopolymer concrete, because for the cement concrete, mainly alkalinity is mainly due to the calcium hydroxide, but for the geopolymer concrete, the alkalinity mainly for the sodium hydroxide used, that means alkaline material. And interesting case for that which we have done, that means the some of the, that means rapid chloride permeability test also, that is also, that is a very good, that means measure for the durability measure, but due to the shortage of time we cannot show the details. So that means what are that which we have found, that means, so that means mainly for the RCPT, that means rapid chloride permeability test prescribed the ASTM 1202, that is mainly for the cement based concrete. We have that means tested whether that can be applied to the geopolymer concrete. Interestingly, we have found out that that means combination of sodium hydroxide and sodium chloride combination prescribed for the cement-based concrete is not suitable for geopolymer concrete, as the chloride permeability in that case, that means is very high and it generates huge amount of heat after a certain time of starting the test, and that means creates, that means the melting of the, that means sealant material, and that means leads to the leakage of the solution. That means, whereas that means potassium hydroxide, potassium chloride combination, that means you have tried with, gives the high chloride permeability, and temperature also rise in that case for the type of geopolymer concrete. with or without nanosilica. So we have tried that is alternate combination of that is that means that means applicable to the geopolymer concrete instead of the that means solution prescribed in the standard concrete as for the ASTM. So we have tried in the other combination, that is calcium hydroxide, calcium chloride, and magnesium hydroxide, magnesium chloride. In case of calcium hydroxide, calcium chloride combination and magnesium hydroxide, magnesium chloride combination, the chloride permeability is low and it does not generate that means considerable heat during the test for geopolymer concrete. So addition of nanosilica also shows the similar trend. So that means that is the need for the change in the combination. That means of anodic and cathodic. That means instead of sodium hydroxide and sodium silicate, so either calcium hydroxide, calcium silicate, because it may be because cement mainly rich in the calcium. So in that case, the combination suggesting that sodium hydroxide, sodium chloride. But as the geopolymer rich in the sodium, that may affect negatively in that case for the geopolymer concrete. So is for the rapid chloride permeability, if that is the combination of the calcium hydroxide, calcium chloride combination, or magnesium hydroxide, magnesium chloride combination, that means can be maybe suitable. So that is as an alternative. That means solutions for the geopolymer concrete. So thank you. So thank you all. This is for my presentation.